Hope you're all having a good day and enjoying your time without me. Today we're going to do a little bit more with completing the square from what we started yesterday. So I'm just going to review the steps with you really quickly. So in order to solve a problem with completing the square, the first thing you want to do is to get the quadratic and the linear terms on one side and the constants on the other side of the equation. So for example, anything with an x or a variable goes to one side, everything that doesn't goes to the other. Then you're going to divide so that the number in front of the x squared, or the a, is 1. Then we're going to take half of b, the number in front of just the linear term, the x, and we're going to square it and add this value to both sides of the equation. Then we rewrite the equation as a perfect square trinomial. That means rewrite the equation as something squared. So for example, after step 3 you may have something like this. And you would like to rewrite this side as something squared. You've created it so that it is a perfect square trinomial so that you can rewrite it as something squared. Then we're going to take the square roots of both sides of the equation and write your answer in simplified form. Remember that almost always when you solve a quadratic equation you have two answers. So now let's go on to a problem where the quadratic coefficient isn't 1. Everything that we've done up till now had a as 1. Here, a is 2. So the first thing that we're going to do is get all the quadratic and linear terms to one side and the constants to the other. So there only is one issue that we have to do here. We're going to bring this 12 to the other side. Now I have 2 x squared plus 6x equals 12. I'm going to leave a little bit of space here so that I can write the constant that I need to there to complete the square. So now the next step is to divide so that a is 1. So here my a is 2, so you have to think about what you need to divide by in order to make a 1. That number is just going to be whatever a is. Here I'm going to divide every piece by 2. So I get x squared plus 3x equals 6. Now I go through and the problem is just like the ones that you did yesterday. You take half of b, so that's going to give me 3 over 2, and then you're going to square that number. That's going to give you 9 over 4, and that's the number that you're going to add to both sides. So here I get 9/4, and here I'm going to add 9/4. This allows the two sides of the equation to still remain equal. So after I've done this, I'm going to try to rewrite this as a perfect square trinomial. Maybe we should simplify this side first. So 6 is the same thing as 24 over 4. So when I add 24 over 4 plus 9 over 4, I get 33 over 4. Now I've simplified that side of the equation. Let's try to rewrite this side as something squared. So that something is always going to be whatever half of this middle term was. So I'm going to get x plus 3 over 2 squared. If you're ever not sure if you're right about that, you can always FOIL this expression out to check that you got what you had in the previous step. So now that we're here, so far we've just rewritten it as a perfect square. Now we're going to take the square root of both sides, and we are going to write the answer in a simplified form. So now let's take that square root. An arrow. That's not negative. So we're going to take the square root of both sides, and that's going to give us x plus 3 over 2 equals. Now remember, when you introduce a square root into the equation, you have to include the plus or minus. So now, let's simplify this radical. Remember that we're not allowed to have a radical in the denominator. Here it's very convenient because you have a 4 in the denominator. So this simply becomes a square root of 33, and we're going to take the square root of the bottom and just give us 2. Now we just have to get the x alone, and we're going to subtract 3 over 2 from both sides to do that. So I get x equals, I'm going to put this number in the front just so that it's a little bit easier to say, plus or minus the square root of 33 over 2. You can leave like that, but here, because it's the same number in the denominator, you might as well write it as -3 plus or minus the square root of 33 all over 2. And that's it for that first example. Maybe we should do our joke of the day now. So, what did one of the math books say to the other math book? Man, I got a lot of problems. Okay, now let's try this example. So the first thing that we want to do is get the problem so that all the quadratic and linear terms are on one side and the constants are on the other. So the only thing I need to do here is subtract 15. So now that I have that, I'm going to leave that space for the term that I'm going to need to write there. So now, so far we have done step 1, and we need to do step 2 now. We're going to divide so that a equals 1. So now, because our a currently is 3, I'm going to have to divide everything by 3. That's going to give us x squared minus 4x equals 5. So now I'm going to do the next step. If you recall, the next step is to take half of b and square it and add this value to both sides of the equation. So half of b would give me negative 2. If I square that, I get 4. And that's what I want to add to both sides of the equation. So now after we've done that, this side is going to simplify to just 9. And I want to take this side and rewrite it as something squared. If you want to think about this, all you're really doing is factoring. So you're looking for two numbers, then multiply to positive 4 and add to negative 4. It's negative 2 and negative 2. So this is going to end up being x minus 2 times x minus 2, which is the same thing as x minus 2 squared. So now that you've rewritten it as a perfect square trinomial, we're going to now take the square root of both sides. Remember that when you introduce a square root into an equation, you need to have a plus or minus. And here I'm just going to get x minus 2. So this one came out nice and pretty. The square root of 9 is just 3. So on this side I have plus or minus 3. On this side I have x minus 2. So I'm just going to add 2 to both sides. So I get x equals 2 plus or minus 3. So now you have to, because these are like terms, you can combine them. You actually should do that. Do 2 plus 3 gives you 5. And 2 minus 3 gives you negative 1. So those are the two answers. These are solutions to this equation, meaning that I could plug them back into the original equation and then give me a statement that's true. So let's try this example now. So now here, the first step I always want to do is get all the quadratic and linear terms on one side, get all the numbers, just the constants on the other. So I'm going to add 10 to both sides. So I get negative x squared plus 4x equals 14. Now I want to divide so that a equals 1. Here, a is negative 1, so I'm going to divide everything by negative 1 so that I have a nice clean equation. That gives me x squared minus 4x equals negative 14. Now I'm going to take half of this term, get negative 2. I'm going to square it. And that's going to give me 4. And then I'm going to add the 4 to both sides. So now I'm going to simplify this side. It's going to give me negative 10. And then I'm going to rewrite this as a perfect square trinomial. It's always going to be x and whatever that number is. If you want to think about it with factoring, that's fine too, like we did in the previous example. Now we're going to take the square root of both sides. But we have a problem here. We can't take the square root of a negative number just yet. We will learn how to deal with imaginary numbers in the future, but at this point, I would like you to realize that the square root of a negative number is not a real number. So at this point, you can write no real solution, meaning that there's no real number that's going to make this equation true. So let's do just one more example. So here I have an equation where the linear terms and the quadratic terms are already on one side, and the constants are already on the other, so I don't have to do step 1. But I do have to do step 2. So here my a is not 1, so I have to divide by 2, everything by 2, in order to make it 1. I get x squared plus 1/2 x equals, I'm going to leave my space there, 3. So now that I have a fraction in this problem, it's no big deal. You still do the same thing that you normally do. I'm going to take half of this term, which is 1/4, and I'm going to square that. 1/4 times 1/4 is 1/16. Then I'm going to add that to both sides. So here I get, let's try to simplify this side of the equation. If I want to add these together, I'm going to need to find a common denominator. 3 is the same thing as 48 over 16. I just did that by multiplying the top and the bottom of that by 16. Plus 1 over 16 is 49 over 16. So now I'm done with that side. Let's try to rewrite this side as something squared. That something is always x, and whatever this number is. So it's x plus 1/4 squared. So now, in order to solve this equation, I'm going to go ahead and take the square root of both sides. That's going to give me x plus 1/4 equals the plus or minus the square root of 49 over 16. So in order to simplify this radical, you should hopefully recognize both the numerator and the denominator as perfect squares. So just go ahead and take those square roots. The square root of 49 is 7. And the square root of 16 is 4. So now I'm just going to get the x by itself, and by subtracting it from both sides. So I have negative 1/4 plus or minus 7/4. Once again, I have like terms here, so I should actually go ahead and do that math. So negative 1/4 plus 7/4 would be 6/4. And then negative 1/4 minus 7/4 would be negative 8/4. Now, I don't want you to leave those numbers sloppy like that, so please rewrite them to look nice. And then I have x equals 3 over 2 and negative 2. So now for our student of the day, today is Gloria. Don't forget to do your worksheet and answer the questions.